Hello, thank you for watching this video. So in this video, I'll be doing question 2 of May-June 2022 question paper, mathematics paper 1. And then this is our patterns. So I'll read question 2 statement and then answer the questions that follow. Okay, 2.1 read as follows. The first term of an arithmetic sequence is -1. And the seventh term is 35. So we are told that the first term of an arithmetic sequence is -1 and the seventh term of an arithmetic sequence is 35. So I've written this statement as well. So we are told that the first term of your sequence is -1, right? And the seventh term of your arithmetic sequence is 35. So let's continue. 2.1.1. 2.1.1. Read as follows. Determine the common difference of the sequence. So they want you to find the common difference of the sequence. So this is the arithmetic sequence. You know the arithmetic sequence of the general term Tn is equal to A plus n minus 1 times D, where your A is your first term and your D is your difference. So you're told that you need to find D, which is the difference, right? You have A, you're told that A is the first term, right? And you're told that the first term of the sequence is -35. So what you can say, okay, Tn is equal to -1 plus n minus 1 times D, right? So this, so we have substituted your first term, your A there. So what you are missing is D. What else do you know? You know that the seventh term of the sequence is 35. So you know that 35 is the seventh term. So what we're going to do, so here our Tn is 35 is equal to -1 plus n is the seventh term. So 7 minus 1 times D. D is what we're looking for. Then we transpose 1 to the other side. We have 35 plus 1 is equal to 7 minus 1, which is 6, times D. Then divide by 6, divide by 6. So you will find that your D is equal to 6. So they wanted us to find the common difference D. Our D is equal to 6. So we move to the next question, 2.1.2. 2.1.2. What does it read? 2.1.2. Determine the number of terms in the arithmetic sequence if the last term of the sequence is 473. So they want us to find the number of terms in our sequence if the last term of the sequence is 473. So you are told that the first term is -1, right? And then your sequence continues, and the last one you are told is 473, right? And you found that your general formula, your nth term is Tn is equal to A minus 1 plus n minus 1 times D, right? And your D is equal to 6. That's what it is. So now, so you're told that this is the last term of the sequence. So now they want you to find how many terms are here in the sequence. So what we're going to do, we take our last term, we substitute it there, and then the only thing that will be missing is the n. So n is telling us the position of this term on our sequence. It is the last term, so where is its position? Where is it on the list of terms that we have there? So if it is the 29th term, that would mean that we have 29 terms on the sequence, since it is the last term of the sequence. So what do? We say, okay, 473 is equal to -1, sorry, plus n minus 1 times D, which is 6. So what you do next is to solve for n. So what do? You transpose the 1 to the side, so 473 plus 1 is equal to n minus 1 times 6, right? Then what do you do? So you have 474 is equal to 6 times n minus 1, right? Divide by 6, divide by 6. Punch that in the calculator, 474 divided by 6. 474 divided by 6. The answer is 79 is equal to n minus 1. So transpose the 1 to the other side. So you have 79 plus 1 is equal to n, which means your n is equal to 80. So now we find that 473 is the 80th term. So if 473 is the last term on our sequence, that would mean that the number of terms in our sequence, so the number of terms we have in the sequence are 80. So we have 80 terms in our sequence. So what was the question? Determine the number of terms in the sequence. It means that now we have 80 terms in our sequence. That's what you say. And we're done with it. So 2.1.3. Went as follows. Determine the sum of the first 40 terms in this sequence. So now they want us to find the sum of the first 40 terms in our sequence. You know, if you want to find the sum of an arithmetic sequence, the general term, the general sum is Sn or n over 2 times 2a plus n minus 1 times d, right? So sum of 40 terms is equal to 40 over 2 times 2 times minus 1, your a, plus 40 minus 1 times 6. So S40 is equal to, you punch this in your calculator, and then the answer that you get is the sum of 40 terms. So we have 40 over 2, then you punch it as it is. 2 times minus 1 plus 40 minus 1 times 6. So the sum of 40 terms is 4,640. So if you sum the first 40 terms, this is what you will get. So yes, we go to the next question. So now I'll clean the board and then we do 2.2. This was 2.1. Sure. Okay. So now we do 2.2. So 2.2, we are given the sequence 75, 53, 35, and 21, right? And you are told this is a quadratic sequence, right? So you know that the quadratic sequence have the second common difference, and the general term is Tn is equal to n squared plus Bn plus c. So now, let's go to 2.2.1. Write down the fifth term of the sequence. So they want us to write the fifth term of the sequence. 1, 2, 3, 4. We are given 4 terms. They want the fifth term. So what do? We say, okay, the terms that we're given is 75, is 53, is 35, is 21. So we want this term here, the fifth one. So what do? We find the difference between each pair of consecutive terms. So now what do we do? Say 53 minus 75, 53 minus 75. It's minus 22, right? Minus 22. Then 35 minus 53. It's minus 18. Then you say 21 minus 35. It's minus 14. Right? So these are your differences. Then you find the difference of your differences. Second difference, which is common. So you say 18 minus minus 2. This is 4. Say, sorry, it's minus 18 minus 2. It's 4. Then you say negative 14 minus 18. That is 4. Right? So for the next term, we're going to add 4 here. Then we get minus 10. Right? And then that minus 10, we're going to add it there. What do we get? We get that this term here should be 11. So we found this. Then you add 4 here, you get 10 minus 10. Then you add minus 10 to 21, you get 11. So the fifth term, which is therefore T5 is equal to 11. We continue to 2.1.2. So we're done with 2.2.1. We go to 2.2.2. So 2.2.2 read as follows. Determine the nth term of the number pattern. So they want us to find the nth term of the number pattern. So you know, this is the quadratic pattern. 2.2.2. The quadratic pattern have the nth term Tn, called an squared, plus bn plus c. It is in this form. Right? That is our nth term. So now we must find a, b, and c of this pattern. How do we do this? We know that 2 times a is equal to the difference, the common difference, which is our common difference is what? Our common difference is 4, right? So divide by 2, by 2, by 2. Therefore, our a is equal to 2. So now we can say our Tn is equal to 2m squared plus bn plus c. So we're only missing the b and the c now. How do we find b and c? How do we find the b and c? We say, okay, T1 is equal to 2n squared. Actually, we want T1, which is term number 1. So we substitute 1 there. T1 is equal to substitute 1, substitute 1. Say T1 is equal to 2 times 1 squared plus b times 1 plus c. So your T1, what is your T1? It's your first term, 75. It's equal to 2 plus b plus c. Leave it here. Do the same thing for the second term, T2. What do you say? You say, okay, T2, then you put 2 is equal to 2 times 2 all squared plus b times 2 plus c. Then you simplify. Say T2 is equal to this times this is 8 plus 2b plus c. You know what a T2 is, right? Your T2 is 53. What do you do from here? We have 2 equations. You solve them simultaneously. You can take the first equation and write it underneath. So you have 75 is equal to 2 plus b plus c. And then find the difference between the 2. So 53 minus 75. 53 minus 75 is minus 22, right? 8 minus 2, that is equal to 6. 2b minus b plus b, 6c minus c plus 0, right? Then transpose the 6 to the other side. So you have minus 22 minus 6, which is equal to minus 28. And that is your b, right? So now you have your b, which is this part here. You're only missing c now. So you say 75 is equal to 2 plus b, which is minus 28, plus c. So if you add these two, you find that 75 is equal to minus 26. And then plus C. So transpose the 26 to the other side. You have 75 plus 26, which is equal to 101. Right? Is equal to C. So you have your A, you have your A, you have your B, you have your C. Therefore, the nth term Tn is equal to what? Tn is equal to an squared, and your A is 2n squared plus bn plus C, which is 101. So this is the nth term here. Then you move to 2.2.3. So this is your nth term here. So I'm going to write it somewhere here. Maybe we might need it. So I'll use the red ink. So I'm going to clean the board and do the last question, 2.2.3. So 2.2.3. Determine the maximum value of the following pattern. So you are given a pattern. They want you to find the maximum value of this pattern. So 2.2.3. I'll write the pattern down. So the pattern is minus 15 minus 53 over 4 over 5 actually, minus 7 minus 21 over 5, and then it continues, right? So you are given this pattern. They want you to find the maximum term of this pattern. The first thing you ask yourself, what pattern is this? So you need to identify the nature of your pattern. What kind of pattern is this? Is it a linear pattern? Is it a geometric pattern, quadratic pattern, or some other pattern, right? So now, let's start with the differences. This minus this, this minus this, this minus that. So now, find the difference. Say minus 53 over 5 minus negative 15. So you get the difference is 22 over 5. So minus 7 minus 5 minus 7 minus negative 53 over 5. Minus 7 minus negative 53 over 5. So it's 18 over 5, right? And then minus 21 over 5, negative 21 over 5, minus negative 7. So it's 14 over 5. So they want you to find the maximum term term of this pattern. We still haven't recognized what pattern is this. Then we continue. Let's say we go for the second difference to see what's up. So 18 over 5 minus 22 over 5. What is it? It's minus 4 over 5. Right? This second difference. Minus 14 over 5. Sorry, 14 over 5 minus 18 over 5. It's also negative 4 over 5. So at this point, it is clear that we have a quadratic pattern here. So that's what we have. We have a quadratic pattern. And if you look at this quadratic pattern, it's very similar to this one, right? Except that these numbers of this quadratic pattern are all divided by 5 to this, by -5 to get here. So this pattern would be equal to this one, to the first one that we're given, if the first one is all divided by -5. So all the terms of the first pattern are divided by -5 to get this one here. Hence you see this guy here and that guy. So this pattern is very similar to this one, but they are differentiated. This one is divided by -5 to be obtained from the original. So now, if you want to get the terms of this pattern, you must divide the terms of the original by -5. So what that means, the general pattern of this sequence will be similar to the first one, only be divided by -5. So what that means is, your Tn for the new pattern will be -1/5 times 2n squared minus 28n plus 101. This is the general sequence for this one, because this sequence is similar to this one, except that it's reduced, or in actually divided by -5. So if you simplify this, it's -2/5 n squared minus 28 or plus 28n/5 minus 101/5. So this is the nth term of this sequence here. So now, if you want the, since we're asked to find the maximum term, we'll have to find the position of the maximum term, right? So you know, to find the position of the maximum term of this sequence is called (b/2a), and your (b) is -28/2 times -2/5. Actually, it's 28/5. It's 28/5 over 2 times -2/5. So this will give you the position of your maximum term. So we use this one. So we say negative of 28/5 divided by 2 times -2/5. The answer is 7. So that means the maximum term of this pattern, our new pattern, or that one as well, is on the 7th position, right? So what we should do now is to find the value of T7. So T7 is equal to -2/5 times 7 squared plus 28/5 times 7 minus 101/5. Then you punch that in a calculator. Then your T7, whatever the value that you'll get there, it will be the maximum value of this pattern. So it's -2/5 times 7 squared plus 28/5 times 7 minus 101/5. So your answer is -3/5. So this -3/5 is T number 7, and it is the maximum term of the sequence. And we're done here. I hope this is clear.